All right, we're back. So in this video, we're going to talk about how to estimate solutions by graphing. Now, graphing may provide only an estimate. In those cases, you can solve algebraically to find the exact solution to the problem. So here's the situation. Emily is going to a local carnival. The function m equals 20 minus 0.75 r represents the amount of money m she has left after r rides. Find the zero of this function. Describe what this value means in the context. So the first thing we can do is make a table of values. So if this function represents the amount of money she has left after r rides, I can look at that and understand that she probably started with $20 and each ride cost 75 cents. You see what I mean? And r is the number of rides. So every time she rides something, you're going to subtract 75 cents. If she rides more than one thing, you're gonna subtract that many multiples of 0.75. So if she rode 10 rides, you would do 20 minus 0.75 times 10, which would be 750. So 20 minus 750 is going to give you 1250. Okay, so that's how this equation or function can be interpreted in the context of this situation. So if we make a table of values, all right, let's start off with zero. She doesn't ride any rides, okay? She's gonna have $20 left. And then if she rides 5 rides, this is how much she has remaining. And then we can graph the related function. Now again, you only need 2 points to graph. It might be helpful to get a couple additional points. Also, in the context of this situation, it doesn't make sense to use negative numbers, and it doesn't make sense to use negative values for r, and it doesn't make, because you can't ride negative rides, right? You could ride no rides, zero is okay. Also, it doesn't make sense if your answer for m comes out negative, because then you'd have negative dollars, okay? So only positive values of r and m make sense in the context of this problem, because you can only have, I should say non-negative, because zero would make sense. Because you can only have non-negative numbers of rides and non-negative amounts of money in this situation. Okay, so we plot the point 0, 20, which is up here, and then 5, 16.25, which you have to kind of estimate right here. And then if you draw the straight line, we go down here. So you can see it's between 25 and 30. It's a little bit less than half. So I'm going to say probably about 27 rides. It appears that the r-intercept, since it's the r-axis instead of x, is about 27. Now, if I solve it algebraically, I would set it equal to 0, add 0.75 r to both sides, then divide by 0.75, and then I get r equals 26.67. So the zero of the function is about 26.67. Now, think about this. Think about this. Emily can't ride a part of a ride. So even though 26.67 technically rounds up to 27, if she tried to ride 27 rides, it would actually cost a little bit more than $20. So she wouldn't have enough money to ride that 27th ride. So in this situation, since you can only ride a whole ride, you can't ride 0.67 rides. She can ride 26 rides before she's going to run out of money. Okay, so sometimes on a graph, it's unclear exactly where it is. You got to estimate it. And then when you solve it, you have to think about what your answer means in the context of this situation. 26.67 would not make sense because you can't ride a partial ride. You have to ride a whole number's worth of rides, so to speak. So she can only ride 26 rides. All right. Okay, here's one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So Antoine's class is selling candy to raise money for a class trip. They paid $45 for the candy. They are selling each candy bar for $1.50. The function y equals 150x minus 45 represents their profit y when they sell x candy bars. Find the zero and describe what it means in the context of this situation. So let me explain the function a little bit. I'm going to guess, since they're selling candy bars for $1.50 and they paid $45 to start for the candy rather, this function represents how much money they've actually made. So if you just sold one candy bar, you'd still be in the hole $43.50 because you only made $1.50 back, but you already spent $45. So we got to figure out how to graph this function. So the related function is 0 equals 150x minus 45, or the equation, and the related function is f of x equals 150x minus 45. Now, if I do a couple values, let's say if I put in 0, you're going to get negative 45, which is down here. If I put in, I'm going to do multiples of 10, because I know that 10 times 150 is going to give me 15. So 15 minus 45 is negative 30. And 5 is real easy because of the way this graph is set up. Not 5, 10. Then if I do another multiple of 10, this is going to be $1.50 times 20, which is going to be 30, and 30 minus 45 is negative 15. So negative 15 over here. And then I can draw my line right there. And it looks like x equals 30 is the x-intercept. Now we can solve it algebraically. 0.5x minus 45 equals 0. So 1.50x equals 45. We added 45 to both sides. Divide by 1.50. And you get x equals 30. So what does that mean in the context of this situation? That means that Antoine's class will have to sell 30 candy bars before they begin to make a profit. So they spent $45. They have to sell 30 candy bars just to make up that $45. And then once they sell the 31st candy bar, they'll begin making a profit to raise money for the class trip. All right. All right, guys, that's it for this section. Please continue on to your assignment. As always, reach out to me if you need any help, and make it a great day.